This video covers properties of exponents. At the start, I have listed out here the 5 properties. When you multiply like bases, you add exponents. When you divide like bases, you subtract exponents, associating those operations, multiplication with addition, division with subtraction. Power of a power, if you raise an exponent to an exponent, because exponents are a shortcut for multiplication, then you multiply. This next property is not the distributive property of exponents. There is no such thing. There is no addition or subtraction here. Instead, if you have everything multiplied together in the base, then you could raise each term in the base by the exponent. The power of a quotient, you may raise the numerator and the denominator separately by the exponent. Look off to the right here in blue. I have several examples about kind of where these properties come from. Whenever you hear that word property, it just means shortcut. So here I have the example, and then I've written it in expanded exponential form. So I go the long way and then literally show you then how the shortcut comes about. I do it here as well, dividing out like factors, showing how the subtraction would work. Same thing here. I take this, multiplying it by itself twice, and then I'm invoking this property. Here, I write this out thrice, and then 1, 2, 3 of them multiplied together, and then same thing here. So that's where the properties come from. If you ever doubt what the properties are, bring them back to numbers. Now, special properties are just shortcuts of shortcuts. Let me show you why a non-zero number to the 0 power equals 1. Here it is algebraically. Let's say they have the same exponent, n and n. So then I use the quotient of powers property. So then that's to the 0. Now, if I use the definition of exponents and expand, that means I have a multiplied by itself n times. So then that's the same number of a's. In the numerator and denominator, they all divide out, equaling 1. So by the transitive property of equality, a to the 0 is equal to 1 when a is different than 0. The negative exponent property, very fundamental for Algebra 2, basically says that to simplify negative exponents, reciprocate the base. Or you move it to the other side of the fraction. If the base is a fraction, you do a swap. Let me show you why this is true. Notice the quantity of 2's multiplied together is greater in the denominator. So when I do the quotient of powers property and subtract, I will get a negative exponent, a difference that is negative. On the other hand, if I use the definition of exponents and expand out, notice when I divide them out, I have one more 2 in the denominator. So by the transitive property of equality, these are true. So negative exponents act as a reciprocation of the base. Working out a couple examples. In this first one, to simplify. Just because you see parentheses does not mean you distribute. There is no addition or subtraction in there. Everything is multiplication. Parentheses are another way of showing that. And it's just this monomial times that monomial. So the parentheses are grouping. Multiply like terms. 3 times negative 4 is negative 12. And then z to the 7th times z to the 3rd is z to the 7 plus 3 power. Because when you multiply like bases, you add exponents. Box answers. In the next example, notice inside you can simplify out the common factors of z. So do that first. There are 3 z's in the numerator, 5 in the denominator, so then that means there are 2 left in the denominator. Or in other words, when you divide it like bases, you subtract exponents, and when you get a negative exponent, that goes to the denominator. So I find that the easiest way to go about this is to do this slash method. So you cross out 3 of those, you subtract 3 from 5, and where there was a greater number, you put the difference, so there 2. So let me rewrite to clarify. And now I will raise the numerator and denominator to the power of 3. So simplify before you do all that, and it'll save you a lot of work in the long run. Now, Z squared raised to the third power, when you raise an exponent to an exponent, you multiply. Feel free to pause at any time if you need to digest. Looking at the next example, we have negative exponents all over the place. We want to go with the order of operations and work on the inside first. So leave this negative alone for now. So anything with a negative exponent moves to the other side of the fraction. So I have 3 such moves. So the x to the negative first in the denominator becomes x to the positive 1 in the numerator. I don't have to write the exponent of 1, but just for now I will. And then y to the negative second will join y to the third in the numerator. Ideally, you multiply them right away and make that y to the 3 plus 2 or y to the 5th, but one step at a time. Next, I want to take that x to the negative 4th from the numerator and make it x to the positive 4th power in the denominator. Now I will multiply like bases here to clean up those y's, and now I will also divide out like factors. So I'm cleaning up everything on the inside of the parentheses before I do anything on the outside of the parentheses. Because I have a negative exponent of an entire fraction, I could raise each part of the fraction to just that negative exponent. And anything with a negative exponent moves to the other side. Or, as a shortcut, I just reciprocate the whole fraction, exchanging the numerator with the denominator. That handles the negative exponent, and now I square everything. When you raise an exponent to an exponent, you multiply. Totally different topic, but related, is scientific notation. It has to fit this form where the first number is greater than or equal to 1 and less than 10. You're not done until that condition is met. So to practice scientific notation, you always put the decimal in there first. And I need to get this 8.3 million to be greater than or equal to 1 and less than 10. So 1, 2, 3, 4, 5, 6 movements. So basically I'm going to divide out 6 copies of 10 to make that number 8.3. And I want it to be equal, so then I tuck the factors of 10 to the right-hand side. This is because we work in the decimal system, base 10. In the next example, we're going to expand scientific notation, so to speak. So this is a very concise version, and scientific notation helps us compactly represent very large or very small numbers and helps us with their calculations. So here the negative means move to the left because now I am dividing this by 10 factors. 4 factors of 10. So I move 1, 2, 3, 4 with that decimal point. And that's its equivalent. Notice that's a very small number, that's why it had a negative exponent. A shortcut is the absolute value of the exponent minus 1 will give you the number of zeros between the decimal place and the first non-zero digit. So the absolute value of negative 4 is 4, minus 1 is 3 zeros. Now let's get down to an application where we have ratios and products of numbers in scientific notation. Caveat, do not take the numbers out of scientific notation. They are in simplest form. Just learn how to handle them in scientific notation by operating on like parts. So these numbers are similar, and this pairing of numbers are similar. So I'm going to take them one at a time, 4.5 divided by 1.5, and times that by 10. Now, I don't recommend using the slash out method here, like any of that kind of stuff. Use the properties. So when dividing like bases, subtract exponents, and in this way, the negative signs won't catch you. So 4.5 divided by 1.5, not too hard to think about if you go ahead and make an equivalent fraction by multiplying out the decimal. 45 on 15 is much easier to think about. It's 3. And when you divide like bases, when you subtract negatives, it's like adding a positive. So then that's 3 to the first power. So that's not a very large number, so you could easily write that as 30, but it did want us to write the answer in scientific notation, so we'll finish there. Usually when you're all done with the problem, it's still very large or very small. 30 would be an acceptable answer there. On the next example, I know there are parentheses, but that does not mean distribution. There is no plus or minus here. So again, we're just multiplying like parts. 2.6 times 8.5. So that's going to give us, and I had 2 decimal places there, so I need to move that over twice. So it's 22.1. And then I am going to multiply like bases with the tens. Doing so, I add the exponents. Negative 4 plus 7 is 3. I am not finished. I need to get that number here greater than or equal to 1 and less than 10. So here's the trick. I'm going to move the decimal over to the left 1. So going from 22.1 to 2.21, that's making a smaller number. But I still want an equivalent answer. So if I make that number smaller by the number of factors of 10, I then will tuck that amount into the exponent. If, on the other hand, I was making a number smaller, like in that example, a smaller number to something that's bigger, 1, 2. So let's see here. If I am making that number bigger, then I need to counteract that amount and subtract factors of 10 so that it remains equivalent. So that would be 3.5 times 10 to the negative 6. Because then when I go out, 1, 2, 3, 4, 5, 6, that would be the same as if from here I went out 1, 2, 3, 4.